Hello everybody, in this video we're going to see about wait function of Linux call and how the process mechanisms will be using the wait function calls to read the processes. Let me explain on the go. I'll be explaining this along with the demo. So I'm going to create a C file, try.c, include normal header files. So yesterday into this where exit is defined, wait is defined here, fork is defined here. Okay. So I'm going to declare one variable r equal to fork system call to create a process. As you know, in the previous videos I have discussed about fork. Fork returns -1. In case of failure of creation of process, fork returns 0 to the child process that has been created. Fork returns PID of the child process to the parent process as a return value. Okay, so in this case, so R of the process address space of the parents will be having more than 0 because PID will be more than 0. R of the child process address space will be having equal to 0 value. So if R equal to 0, so here I am writing a code, say while of 1 infinite loop. So this part of while is entered by child. Okay. In child's text area, this whole code will be there, but child will be entering this one. Okay. The same way, the code will be there in parent address, parent area also. So the parent enters in the else part and we are exiting. Parent is exiting. So if you see this one, this is a child running, parent exited. If you see PS again, see 6 seconds. Parent, so PS again, 11 seconds, 13 seconds, 15 seconds. Like this, child is running. This is the idea of the child. 42080. This is the idea of the child. But parent exited. Parent exited. So this is the example for orphan process. We are already seen this one. But if the process child is finished this loop, in this case it will not finish. But if there is a child is working on something, at that time parent exited. During the working we say it's an orphan process. But after the working of the child is also over, child will also exit. But before the child exiting, parent has exited. So in that case, child does not read. So the child will be a defunct process. Child will be a defunct process. Because parent has exited and child was working at that time. Or when the parent is sleeping and the child has exited, parent is not there to read it. So we have seen that continuation also in the previous examples. When the parent was sleeping or parent was working when the child exited, so child sneaked out without informing the parent. Then we say it's a zombie because the child's ID will be there in the table, but it will not be there, but only the ID. So then we say it's a defunct. So here, child is running and the parent should not be exited. Parent should wait for the child to finish to read it. So in that case, instead of exit, I'm using wait. Okay, put a wait. Parent will wait. Wait here. Parent will wait till the child finishes. Now if I run this code, I'll show you what's happening. See, the parent is waiting. That is why I'm not able to see the shell. It's blinking, it's waiting. Child is also running. Now, I'll stop and show it to you. But previous child is also still running. Before that, okay, I will just kill it. Yes, I will kill the previous time Warner return was running. This one 420. I kill this one. Okay, clear. Now we have parent house. So it is there. Parent is waiting, but the child is put up in the while loop, infinite while. Parent is waiting for the child to finish. So parent is not exiting. So parent waits for the child to exit. Because wait function means it will wait for the child to exit. Then it will read the child's ID from the process table. Then it will exit. Otherwise, child will be a zombie. Child will exit, but it will not be read by the parents. Now I am putting a stop. Let me see what is there. See, there are two things. 101, 102. 102 probably may be the child versus a bigger number. Usually that's the case. So child is running in a while loop, and the parent 101 is still running. It's still running because it's waiting. It's put on the wait mode. For this exit means this one will not be there. Only you will be seeing 20102. So it is in the waiting. So it is waiting for the child to finish and it will read it. Okay. So proper code is like this. Whenever people used to write process like this, when a child walks for something, say for example, plus I equal to 1. Just do a thing. Plus I, it's happening. Okay. I start from say minus 100. So this loop runs for minus 100. So around 100 times it will run, because when this equal to 0, then the while loop will be out. So the child is running, but the parent is waiting. Parent didn't exit it. Child is given some work, but parent is not given any work. They're just waiting. They're just waiting. Okay. So parent will come here. Then after this child got over, okay, after the child got over, it will be coming after this one. Okay. So if you just printf after the child got over, then only it will be coming out. So I can just say child finished. Child finished. Okay. So let us just see what's the value of while loop. Printf. I'll just print the I value. I equal to plus ht. I will be 0 because it will exit and then it is 0. I'm doing a pre-increment. So when this I becomes 0, it will exit, and then I will print I equals 0. So after the child is finished, because it goes here, it goes to this one, child is exited. Then voice will inform the parent that child has exited. Then parent will read the child inside this wait function. Then it will start running. Child finished, message will be coming. So first it will print this one, then it will print this one. This is how I usually do. See, I equal to 0, child finished. That's all. So I cannot just throw and print I here, because this is entered by parents. Parent I was having some junk value, so that same I will be preserved, because it's a different process address space entirely. This I is in different I, because it's a local variable. So at the time of creation it will duplicate the whole thing. So at the time of creation it will be same, but after I assign with a minus 100. Okay. Then it's in the stack, it just doing, it's in the child's processor space. But the parent's processor space will still have the I equal to junk value. That's why I'm not printing actually here. So, but this is finished. After this printf only, this will printf will be encountered. That's what I mean to say. So, child process should not exit. Okay, or I can say parent process should not exit before the child. Otherwise, who will be there to read the child? So, parent process should wait. So, whenever the parent process is going to end, at the last line, they will add a wait call. At the last line, the parent will be doing its own job. After that, they will put a wait. It will wait for all the children to be over. All the children it has produced to be terminated. Then only it will just terminate. So what wait function will do? Wait function will read all the children once they are terminated. That means once they are done with this function. Means the child is done with the whole thing. It is exited. Once the child exited, it will inform the parent will read it. Only if it calls wait on the child. So the meaning here is parent will wait on the children to read it. Otherwise child will exit, but the ID will still be in the table. The defunct ID you will be able to see, the zombie ID. So if a parent is not there to read the child's ID will be there. Okay. So if a child exited while the parent is running, at that time also you can see difference. Okay. The parent was doing something else. It's not calling wait. The parent didn't come to wait. Parent was doing something else. At that time child has exited. So once when the parent hit the wait, then only it will repeat. That's a different scenario. Okay. So all the other scenarios here, what I mean to say here is, if you see this process, what we are making sure that the parents should not exit before all the children exits. So parent will wait for all the children it has created, then it will come out. So that is why we are calling wait on the children in the parents. Okay. Thank you.